Hi everyone, in Algebra 3, this is going to be your questions on problem set 57, part 1. I have split it into two separate videos. So looking at number 1, we have 6 red marbles, 4 blue marbles, and 2 white marbles are arranged in a row. How many distinguishable permutations were possible? So for this problem, we are going to identify that there are, in total, there's going to be 12 marbles. So our equation is going to be n factorial over the number that are like factorial. So a factorial, b factorial, c factorial. N is your total number of marbles. So again, I said 6 plus 4 plus 2 is going to be 12 factorial over the number that are like. So I have 6 red, so 6 factorial, blue factorial, and then white factorial. So 12, 11, 10, 9, 8, 7, and then 6 factorial over 6 factorial times 4, 3, 2, 1 times 2 times 1. So the 6 factorials would cancel. Then we could do 4 times 3 is 12, and then 2 times 2 is 4, so this would make this 2. So that would be 11 times 10 times 9 times 2 times 7. No. 11 times 10 times 9 times 2 times 7 equals 13,860. So distinguishable permutations means you're going to use this formula right here, the n factorial over the number that are like factorial. Moving on, number 2. So again, this one says how many distinguishable permutations can be made from the letters in the word abracadabra. So for number 2, I'm going to use the same formula, but my n is going to be the total number of letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. And then I'm going to count the number of doubles. So A, I have 1, 2, 3, 4, 5 A's. Number of B's, I have 2. And number of R's, I also have 2. So now for my formula, n factorial over the number that are alike. So this would be a factorial, b factorial, and then r factorial. So my n again is 11 factorial over 5 factorial, 2 factorial, 2 factorial. So 11, 10, 9, 8, 7, 6, and 5. Over 5 factorial times 2 times 1 times 2 times 1. So really what we could just do on this one would just be to do 11 times 10 times 9 times 8 times 7 times 6, and then just divide that all by 4. And that would give you 83,160. Same type of problem as number 1. Is the distinguishable permutation equation. Now moving on to number 3, it says 400 radians per minute sounds fast, but the wheels on the tiny car had a radius of only 4 centimeters. What was the velocity of the car in miles per hour? So for number 3, we have the formula V equals RW. They actually give us what the radius is. The radius is 4 centimeters. And they also give us the angular velocity, which was 400 radians per minute. Remember that radians can be taken out or added in as needed. And in this problem, I don't need it because I just need to convert from centimeters to miles and then minutes to hours. So the first thing I'm going to do is to convert to inches. So 1 inch is equal to 2.54 centimeters. Then to feet, so 12 inches is equal to 1 foot. And then miles, 1 mile is 5,280 feet. So our feet cancel, our inches cancel, and our centimeters cancel. So I'm left with miles. And then I have to get minutes to hours. So 60 minutes in 1 hour. And the minutes would cancel. So your answer is now going to be 4 times 400 times 60 over 2.54 times 12 times 5,280. That's going to be miles per hour. Moving on to number 4, same type of problem. This one says, another little car went by at a speed of 40 kilometers per hour. What was the angular velocity of its wheels in radians per second if the diameter of the wheels was 10 centimeters? So this one, using the formula V equals RW, we're solving for angular velocity. So I'm going to multiply both sides by the reciprocal of the R, which means that for number 4, the formula we're using is angular velocity W is equal to velocity times 1 over the radius. Now, we are given what the velocity is. It says 40 kilometers per hour. We're given the diameter of the wheel is 10 centimeters, so therefore the radius is going to be 5 centimeters. And now what I want to do is I want to eliminate all my units of measurement so that I can add in the radians and then convert hours to seconds. So I know that there's 100 centimeters in 1 meter, which would cancel out my centimeters, and then 1,000 meters in 1 kilometer, which would cancel out my meters, but it would also cancel out my kilometers. Then I need to get it from hours to seconds. So 1 hour, 60 minutes, and then 1 minute, 60 seconds. So now I have in my numerator, I would have 40 times 100 times 1,000 over 5 times 60 squared. And remember, so there's no more unit of measurement. If you look in the numerator, radian can be added and or taken away as needed. So radian per second. And that would be your answer for number 4. Moving on, we're going to look at number 5. So number 5, we have the tugboat Mary Beth could go 24 miles downstream in 1 hour more than it took to go 8 miles upstream. If the speed of the Mary Beth in still water was 3 times the speed of the current, what was the still water speed of the Mary Beth and the speed of the current? So it says 24 miles downstream, so the distance downstream is 24. The time downstream is 1 hour more than it took to go upstream. So time up plus 1, and your distance up was 8. If the speed of the Mary Beth, so the boat, was 3 times the speed of the current. So now you have 2 equations. You have our downstream and our upstream equation. I'm going to plug into those. So if my B is equal to 3W plus W times TD, which is TU plus 1, equals DD, which is 24. When I combine the 3W and the W, I get 4W times TU plus 1 equals 24. And what I would do on this one is I would multiply this equation by 1/4 and then distribute the W. So that would be WTU plus W is equal to 6. Now for my upstream equation, I'm going to plug in my B, which is 3W, minus W times TU equals 8. 3W minus W would be 2W TU equals 8. And if you divide by 8, you get W TU is equal to 4. Once you know that, you can take the WTU is equal to 4 and plug it into this equation. So I have 4 plus W equals 6. So therefore, the speed of the current W is equal to 2. And then for my speed of my boat, it's 3 times the speed of the current. So the speed of the boat, or the Mary Beth, is going to be equal to 6. And that concludes number 5. Moving on to number 6, the latitude of Charleston is 38.5 degrees north of the equator. If the diameter of the Earth is 12,000 kilometers, how far is Charleston from the equator? Well, this formula is going to be distance is equal to x degrees over 360 times pi times diameter. So my x is going to be 38.5 degrees. And then my diameter of the Earth is going to be 12,000 kilometers. So when I multiply this through, you're going to get 38.5 times pi times 12,000 divided by 360. And that will give you a result of 4,031.71 kilometers. Moving on to number 7, the number of boys who came varied directly with the quality of food. If 100 boys came when the food quality was 2, how many came when the food quality was increased to 40? Okay, so the number of boys varied directly with the quality of the food. So for number 7, for our very directly equation, it's going to be the B1 over B2, and it varied directly as the quality of the food, so it would be Q1 over Q2. Okay, so that's our very directly done in ratios. So the number of boys was 100 when the food quality was 2, so this would be 100 equals 2. How many came when the food quality was increased to 40? So this would be X over 40. Cross multiplication is going to give us 2x is equal to 40 times 100. Divide by 2. So we get the number of boys would be equal to 2,000. And moving on, we're going to look at numbers 10, 11, and 12. So for number 10, we are trying to find the area of this triangle. So for number 10, we're trying to find the area of the triangle. And what we're going to do first is we're going to start by creating a right triangle within this triangle. So I'm going to create the height right here. Notice that to 74 degrees, the height is opposite of the 74 degrees, and the 9 would be the hypotenuse because it would be opposite of the right angle. So you're going to use sine equals opposite, which is the height, over hypotenuse, which is 9. Now when you multiply this through, you want to leave it on your calculator, so it would be 9 times 74 sine equals, and this is going to give us a height is approximately equal to 8.65, but I'm going to leave that in my calculator when I try and solve for the area. So the area of a triangle is base times height divided by 2. So 1/2 the base, which is 10, times the height, which is approximately 8.65. So when I divide the 10 by 2, I get 5. So all I need to do is multiply my current height times 5. And that will give me an area of 43.57. And that's going to be centimeters squared. So don't eliminate the height from your calculator when you're evaluating. Now moving on to number 11. So the first thing that we're going to do is we're going to create a right triangle, but this time it's going to be on the outside of the triangle. So 9 is still going to be my hypotenuse. This is going to be my height, but my angle is going to be the supplemental angle to 125. So I'm going to do 180 minus 125, which gives me 55. I'm going to do the same thing. So the sine of 55 equals opposite, which is the height, over the hypotenuse, which is 9. So now you're going to have 9 times 55 sine equals, so my height is approximately equal to 7.37. And again, I'm going to leave that in my calculator when I'm evaluating the area. So area is 1/2 the base, which is 7, times the height. So on this one, I'm going to multiply my height times the base and then just divide that whole thing by 2. And that will give me the area is equal to 25.8. And that's in centimeters as well. So centimeters squared. So I never eliminate my height until after I use it to solve for the area, because that will give me the closest answer. And then lastly, we're going to look at number 12. So for number 12, it's very similar. Again, I'm going to create a right triangle within my trapezoid. This is my right angle. This is my height. Now, my 16 is going to be my hypotenuse. Height is the opposite. So it's going to be the sine of 65 equals opposite over hypotenuse. So in my calculator, it's going to be 16 times 65 sine equals, and I get my height is going to be equal to 14.5. But again, I'm not going to eliminate that because I'm going to do the area of the trapezoid is equal to 1/2 the height, which is 14.5, times base 1 plus base 2, so 10 plus 20. 10 plus 20 is going to give me 30, so I'm really just going to multiply my height times 30, and then I'm going to divide it by 2, which gives me the area is equal to 217.51 feet squared. And that concludes part 1 of your questions on lesson 57. I hope you have a great day.